Alrighty, let's go ahead and get to some more of these. Definitions. Again, you will have an intuitive understanding of a lot of these. I just want to make sure, again, we're on the same page. Okay, this page will be easier. The next page, there's some specificity to it, and I'm going to need you to pay special attention to that. But for here, coefficient. Coefficient basically, if you have a term basically the coefficient is the non-variable factor of a term, right? Or, the number sitting out in front. Degree is basically, the sum of the exponents of any particular term. Okay, so let's go back to what we had here. The degree of this term is actually 3, right? Because you have 3 variables, x, a y, and a y. Here, it is also 3. You have an x, and a y. Here, the degree is 2. Here, the degree is 4. You have an x, a y, and a y. So you have a total of 4 variables, okay? So basically, the degree winds up being the sum of the variable factors of a term. Okay, and oftentimes we'll be dealing with functions where it's it's not equations of like 3 variables, and there's not going to be a whole lot of blending. We're going to be dealing with functions where with the exception of the f of x over on the left side, all of the terms are going to be in terms of a single variable. So the degree winds up being really, really easy to figure out. Okay, now. Independent variable and dependent variable, and those are oftentimes also basically synonymous with input and output. Okay, the independent variable is basically your input. It doesn't depend on anything, right? And if you've sort of, especially just think about graphing. When you think about a graph, you're just thinking about nothing, the x values that you're plugging in, if it is indeed x, right? The x values that you're plugging in, you're just plugging them in. And you plug them in from negative infinity all the way to infinity without regard for anything else. They sort of are independent. All right? And so, but what they actually produce are the outputs. And those outputs are not every single value from negative infinity to infinity. They definitely depend on the form of the function. The form of the function basically, and of course all the inputs that are put into it, will give you your outputs. So when we're dealing with independent variables, you sort of almost defined it here by the input. It is the variable that sort of receives, I guess is the best, that receives the input values. Okay, and this is the variable that represents, and actually they both represents the output values. Oftentimes, for a function. Okay. And I'm not too keen on making sure that those are really, really hard and fast, but you need to remember that independent and input go together, dependent and output go together, and that's basically the thing. Now, exponents, and you can think about exponents in a number of ways, and oh my, I've actually. Remember when we talked about today, I basically referred to multiplication as a shorthand for lots of the same addition. And oh my gosh, I've seen a college professor on a video just like get really, really up in arms about how it's really, really bad that high school teachers teach their kids that that's what multiplication is. Well, that's not all multiplication is, but it certainly is one of the things that it is, and it's certainly one perspective on that, okay? And in like fashion, exponents, this is basically one, because of the way that we're going to be using exponents, I want you to think about exponents in this way. But when I give you some of these definitions, you need to understand that these are not exhaustive in terms of plumbing the depths of what multiplication, or in this case, exponents are. An exponent, for our purposes, is the enumeration. Remember, it counts, it enumerates, the enumeration of lots of the same multiplication, right? So if you have, 2 cubed, 3 being the exponent, tells you how many times you do the same multiplication. You multiply 2 by itself, okay? A radical is obviously the inverse. Okay, so first of all, this is the inverse of an exponent. Okay. And it basically, it doesn't enumerate lots of the same multiplication. It asks the question, how many, let me put it this way. If I have x squared, this basically means x multiplied by itself 2 times. The square root of x asks the exact opposite question, which is, what number multiplied by itself, and since it's the square root, it's implied 2 times, right, is x. So, this is x multiplied by itself. This is what multiplied by itself is x. And so you can see how, even when you basically write it out in terms of their verbal expression, you can see the inverse relationship, okay? And so a radical is basically, it's basically asking yourselves questions from another perspective about exponents, okay? But basically, it is let's just call it the inverse of an exponent. That's probably the best way to do it. Now, an exponential, and we have to be careful with this. Remember, an exponent is what we refer to when it's like x squared, right? We say x has an exponent of 2. An exponential, right, is when it's instead 2 to the x. And its inverse is obviously a logarithm, okay? But 2 to the x is not x multiplied by itself. It's 2 multiplied by itself x times, right? But the great thing about exponentials is that they still abide by the rules of exponents, okay? So, I mean, you can still, if you have something like 2 to the 2x, right? This is still, 2 squared times 2 to the, or no, this is, sorry, that's not correct. It's 2 squared to the x, right? Or 4 to the x. Or if you have 2 to the 2 plus x, that's 2 to the 2 times 2 to the x, or 4 times 2 to the x. So they still abide by the rules of exponents. And the rules of exponents, most of them require the same base, right? That similarity of base. But you need to remember that's an exponent expression. This is an exponential expression. And exponentials are, of course, useful for any time you need to multiply something by itself again and again and again and again and again. And if you don't remember, that's like interest problems, right? The question is not what are you multiplying by itself twice. It's how many times are you multiplying 1.05 by itself. And so you have those expressions where it's radioactive decay, half-life, there's population problems, there's interest problems, and the like, okay? But exponentials basically, gosh, I mean, how would you define an exponential? That's kind of actually a tough one. I'm totally blanking about what I usually say about that. Basically, it's instead it's a known number multiplied by itself an unknown number of times. And some of these definitions that I'm putting on here are not so much that I want you to be able to explicitly do it, but I'm really interested in you remembering the distinction between those. So an exponent is an unknown number multiplied by itself a known number of times, and this is a known number multiplied by itself an unknown number of times. So basically you've swapped the known and the unknown, right? So an exponent is an unknown raised to a known, and an exponential is a known value raised to an unknown, okay? And so that right there is the difference. So for example, this, like the examples that I gave, that's x squared and that's 2 to the x. Okay? Alrighty, the last video will be coming up next, and those are going to be a little bit more important in terms of having those definitions down tight. As always, if you have any questions, please do shoot me an email. Bye.